Let's get started. This is our meeting of the Warren Astronomical Society, partly in person, partly online. In person, we're here at Macomb Community College. I'm filling in for Bob Tremblay, who's out in Arizona. And I don't know if he's managed to log in or not, but I'm the first vice president, so it falls to me when the president's away. In our in-person audience here, do we have any first-time or near first-time people? Can you give us your name, not nice and loud?
Troy.
Troy? And how did you find out about us?
I've always been into astronomy, like membership. You kind of know about it.
So, boy, Troy's wife got him a membership, and he didn't even know she was going to do it.
My wife got me involved in the board here, and I didn't even know she was going to do it.
Do we have any new people online? If so, unmute and show us your video and say hi.
You want to put them on screen?
If I knew how to do it. Jonathan Kade is suggesting we put them on the screen.
Let's oops, sorry. Okay. Oh, why is it?
There's a mouse right there.
Well, that's it. What is even happening? There you go.
Okay. So a reminder to everyone who's a member, renew your membership for 2024 if you haven't done it already. I don't know if our treasurer is going to make it tonight. But you can always do it online, either on the website or through PayPal. Let me get my spectacles back on. And also, if you want a membership tag, and I left mine out in the car, wouldn't you know it? For this organization, you can let publications know that, and we'll get you one. While this is a tough thing to do when we've got an online audience, we still do what we used to do and go around the room and have everybody give your name, and if you're an officer, say that. So let's start in the back corner.
Charlie Strackline, Mike German, Eduardo Salusa.
Jeff McLeod, what am I now? Outreach.
Hey, I have back to me.
Jeff McLeod was trying to remember what office he's currently holding. Troy?
Diane Hall.
Jonathan Kade.
Okay, the last two are Diane Hall and Jonathan Kade, both former officers and both former presidents, in fact, of this August organization. Glad to see you guys here again. Okay, so for those who are present here, Mark Kedzier's in the back. He still has some calendars that can be purchased. For the people online, you can purchase them too. Just let us know. We'll send them to you. And we have Warren Club wearable merchandise that Mark Kedzier can sell you. In terms of officer reports, as I mentioned, Bob Tremblay's in Arizona with a guy he works for, Brother Guy, at a workshop run by Vatican Observatory in Arizona. My report is I always need more speakers. I somehow grabbed Jonathan when he wasn't expecting it, twisted his arm about 3 times around and got him to agree to speak tonight, and the same with Diane coming soon. But if there are people either online or here in the room who have something they are thinking they could give a presentation on, please let me know. So, didn't I see Riyadh somewhere or online? How about unmuting Riyadh and telling us something about your duties?
Yes, hello everyone. Of course, for this year, I'm going to.
Can you talk louder? Wait a minute.
Okay, can you hear
Technical
now?
help is on the way.
Oh, man, this is
Oh.
really bringing back the memory. All right, go ahead, Riyadh.
Okay, how about now?
Much better.
Okay. Yeah, so for this year, I'm going to be your observatory chairman, second VP. And first of all, I'd like to thank Jeff McLeod for 2023 being such a wonderful year for Stargate. And hopefully we will have some good observing nights this year as well. I want to mention that I had a report in the WASP. If you get a chance, please read that, for especially for the events that are coming up this year. And our first event is going to be in 2 weeks. So Saturday, the 27th, is going to be our open house. So I hope to see everyone there. If the weather is really bad, very dangerous to drive, I will cancel the session. But other than that, I'll be there at least for a while in case somebody wants to show up. And hopefully we'll see some people out there.
Okay.
Hopefully it'll be clear. Yeah. Thank you.
Yes. That would be nice. Okay, thank you, Riyadh. So David Baranski, I don't think he's online or
This
here.
Yep, I just came online.
Okay, great. Can you give us your treasures report?
Well, let's see. So I about a half hour ago, I met with Adrian, and I actually have the cash box on hand. We do have to meet at Bank of America to kind of do that handoff. I think that might occur towards the end of the month. But like I said, we kind of have to pick a place and time to do that. So that's kind of ongoing. We did have a couple of new memberships. We did have, I think we've got about 24 grand in the account. And relative to doing the handoff, I'm not sure if we need just myself and Adrian or some other members of the board to be at this meeting with the bank. Does anybody know by chance?
I think you guys are going to have to figure that out between
Okay.
yourselves.
All right. But that's the treasury report at this point.
Okay. Charlie,
Yes, hi, I'm Charlie Strackbine.
come on up to the microphone.
Come up to the, okay.
The people online can't hear you so well
Right.
over there. Yeah.
Hey everyone, I'm Charlie Strackbine, and I'm here to be your secretary of the club. And I don't have much to say today, but I am developing a system to best keep the notes here, so that we have a record what we're doing going forward. And I do have something I'd like to include in the meeting somewhere, and that's I have an interest in where's everybody going for the solar eclipse. And I just thought that'd be nice to talk about or put on the record. I think that's a big thing for anybody in astronomy, and especially our club. So I think that'd be pretty cool to keep track of that. So that's my report for now, and I look to have more as my system of recording the meeting minutes comes more clear for me. Thank you.
Okay. Thank you, Charlie. Our new secretary. Jeff.
Yeah, so the observatory is doing pretty good. No outreach scheduled events just yet. We've got requests for eclipse stuff, so if you have one in the can, I know there's a couple of people in the club that definitely have one. I'll be reaching out to you if I get requests, or if you want to reach out to me, that'd be even better. Everyone else, for general outreach stuff, if you're interested in participating, let me know. I'll get you on the list of people I contact when libraries, scout groups, all kinds of different things come down the.
Is it pipe or pipe? Pipe.
Which is
I mean, it
open.
could go either way.
It's an
really.
open pipe, right?
Well,
It's like a V trough.
think of it
That's
as
what a pipe
Mario.
is.
Mario's on the list.
And then it's not really the outreach duty, but I was in charge of discussion groups last year and they kind of just trailed off into nothingness. So this is my friendly reminder. If you want to host a discussion group, you can let me know or you can contact maybe publications because that's where we're going to advertise the discussion group to the newer people. Traditionally in years past, every month a member would host a discussion group at their home. Usually, I don't know, 8 to 10 attendees, and you can kind of tailor it to what you want. If you want there to be a theme, a particular topic, open forum, bare knuckle boxing, however you want to handle it. I think that's it. Let me know if I have other responsibilities.
See if I can think up some for you. Okay, now Vatshalia, I know could not make it in person and I don't think online, but are you there, Vatshalia? Okay. She's in charge of publications. Dale Teamy, do you want to say anything about that?
Okay, I can do that. Well, naturally,
Dale is the WASP editor. Go
okay.
ahead.
Okay, well, naturally, the January WASP is online, available for anybody who wants to read it. I just finished up on the annual mailer and processed that, and that's going to be sent out probably today or tomorrow. And I think it's already been pointed out, we still have calendars to sell. But when you get the mailer, be sure to check your membership date, see if it's expired yet or not, and see if you need to renew it. That's my
Okay.
report.
Thank you. So let's see. Astronomy and News. I didn't have a chance to take a last minute look at what's new. I think our main speaker is going to have some new things to tell us about. He mysteriously told me.
Not super new, but newer. You might not have heard.
Newer. Okay. Anybody
In the
else?
last 12 months.
Anybody else aware of any recent news? Come on up, Diane, so they can hear you too.
Uh-oh.
Where's the mic? Oh, just right in there?
Yeah, in the laptop.
Hey, y'all. So, the saga of the Peregrine Lander, which was the lunar lander that was privately built by the company Astrobiotics, that was bound for the moon, containing a payload that included the ashes of Gene Roddenberry and several Star Trek actors, and DNA samples from dozens of luminaries of Earth, including multiple American presidents, going back to George Washington. So this caused a bit of a stir because Navajo tribe lodged an objection to quote unquote polluting the moon, which to them is sacred. Which is kind of interesting because we already know from the Apollo missions that we used it as a restroom. So that ship has sort of sailed. Anyway, Astrobiotics and NASA did not care. The rocket was a new Vulcan-style rocket. So this was a test of new technology. Unfortunately, shortly after takeoff, the probe suffered a rupture in one of its fuel tanks, kind of Apollo 13 style, that caused a lot of the propellant to leak out, making it impossible to do a soft landing on the moon. You need fuel to execute the burns that would put you into a proper orbit and then take you down. So after a couple of days of speculation as to whether or not it was going to just drift off into space forever, they did a slingshot around the moon. So it got to the moon, in a sense, the same way Apollo 13 did. And it re-entered Earth's atmosphere earlier today and burned up, I believe, over the Pacific Ocean. So
The Pacific Ocean, that's sacred.
yeah,
Can't pollute this.
so all of the human remains incinerated again in Earth's atmosphere and rained down.
It's still pretty cool. though.
It's still pretty cool, but yeah. So much for the DNA sample. So that was the unfortunate saga of the latest American-backed attempt to do a lunar lander.
Was the idea that this would be like a time capsule for this DNA? That's amazing.
Yeah, Jeff McLeod asked if this was the point of sending human remains and DNA was that it would be some kind of a time repository, you know. Yeah.
And the beings in the future might have the technology.
Exactly, yes. Everyone else, I love the idea of Gene Roddenberry's ashes.
Yes, Gene Roddenberry's ashes. It was a good idea, but yeah, no, didn't happen. Back to the drawing board. And my favorite phrase, space is hard. We proved that again this week.
So wait a minute. Do the people whose ashes didn't make it get a refund?
Ooh,
Too soon.
yeah, too soon.
Okay, that's an earn.
Jim Shedlowski said they would have to earn it. Okay, so we're about to have David Levy speak to us, but I'd just like to prime people, both online and here in person. After David speaks, we're going to have a chance to ask an astronomy question. So you can be thinking about whether there's some kind of astronomy question you'd like to ask. And don't worry if you don't know much about astronomy and you're afraid it'll sound like a dumb question. Those are good questions, okay?
Reminds me of
The old days.
Ask a stupid question.
Yeah. Yeah, I know. We used to do that a lot. Anyhow, David,
Well,
you have
thank you.
something for us.
Thank you very much. It's good to be back here. And I wanted to wish all of you a very happy new year. May you only get good things in 2024. A big discussion right now is what's coming up on April the 8th, a total eclipse of the sun. And many of us will not be in the path of totality. I will be in southern Texas. But for those who are not, you will see the sun as a crescent with a dark moon in the background. Anyway, my poem tonight is actually from the Rime of the Ancient Mariner, and that will eventually lead into writing about an eclipse. But in order to do that, we needed a revising poet, Leslie Peltier, to change the words a little bit. But here's the original. The sun's rim dips, the stars rush out. Out of one stride comes the dark. With far heard whisper o'er the sea, off shot the spectre bark. We listened and looked sideways up, for at my heart, as at a cup, my lifeblood seemed to sip. The stars were dim, and thick the night. The steersman's face by his lamp gleamed white, from the sails the dew did drip. Till climb above the eastern bar, the horned moon, with one bright star within the never tip. And what we did was Leslie Peltier in Starlight Nights revised the last two lines that I just read after he saw for him, a very deep partial eclipse in 1918. And he said, he changed it to a horned sun with one dark moon within the nether tip. I hope we all get to see a total eclipse of the sun. Remember that the difference between a 99.99% eclipse and a total eclipse is everything. So you really want to be within the path somewhere. Anyway, back to you, and thank you for letting me do a little poem today.
Okay, thank you. Let me see. I'm trying to figure out how to,
Click remove pin there to the left of the word live.
okay, before we get to ask an astronomy question, we have a couple more things we might want to cover. Riyadh, do you want to say anything about double stars? You're muted, Riyadh. You're muted, Riyadh.
Oh, here we go. Yes, thank you.
Sure.
Yeah, of course, for double stars, we have micrometer eyepiece that we purchased a few years ago. I'd like to go back to using that. Dale, if you remember, you and I tried it out one night to try to calibrate it. So that's one thing that we would be looking to use when the sky clears up at the one of the open houses. So hopefully we'll be able to do that soon.
Okay, thank you. Any other special interest groups to report anything? Okay, so astronomy questions. I'll start with the group here in the room. Does anybody have an astronomy question? Everybody knows everything. Yes. Come on up here. And give your name.
I feel like I'm testifying before city council meeting here. There've been a few of those. Okay, my name is Mike Gerben, and we had that discussion about the craft that tried to land on the moon. And there is a lot of discussion, at least on the news media, about the solar panels. I was just trying to understand. We went to the moon before, but we didn't need solar panels. So I'm trying to understand how that was so critical in the discussions, at least in the news, about the solar panels on a craft. So maybe somebody knows the answer to that. And I'm looking at Diane here. Her fingers are moving across the keyboard.
So,
What was it gonna do when it landed?
I honestly, I wasn't even paying attention until
Till it started
till
going.
it started going wrong, yeah. So,
I'm just for sake of the audience on the other end of this.
yeah,
Zoom
I don't really know too much about the design of the lander.
But it was very disappointing, and we everybody wanted to see that succeed.
So like a lot of the stuff that.
Okay, I have Jonathan coming up here.
So the Apollo mission brought various things to the surface of the moon. So they brought retroreflector panels, but those are totally passive. So what you do is you shine a laser at the moon from Earth and it reflects it back. So they didn't have to be powered. While they were on the moon, they had power from the landing module. But then in terms of all of the autonomous landers that we had done before, I think those all had solar panels or they had fuel sources that didn't last as long. But back then they didn't expect a lander to last very long either. So Diane.
Yeah, Apollo used fuel cell technology.
Okay, come on up here.
Apollo used fuel cell technology.
Okay.
So the issue of the solar panels, it didn't matter because they had a different way of actually doing it. And so one of the reasons to use the fuel cell was that they produce water as a bioreaction, which obviously humans need water. Passive lander, scientific experiments doesn't need that, so you don't need the whole cell. Yeah, so.
Well, that's a lot more than I knew when I get here tonight. Okay, thank you, Diane. Thank you, Jonathan. And I'm going to return this back to Dale.
Thank you. Yeah, typically when we put uncrewed vehicles down on the lunar surface, depending on how long they're expected to last, they have batteries. That's what the craft actually runs off of. And whenever there's sunlight hitting their solar cells, they recharge the batteries. The problem with Mars doing that on Mars is that solar cells gradually get coated with dust. And then the craft stops working, like the InSight lander, working perfectly until the cells got too coated with dust and they couldn't power it anymore. Just a second. The Curiosity and Perseverance rovers are using nuclear power to power them. It's not like there's a nuclear reactor there. It's just a radioisotope that gets hot, and they can derive heat. They can turn that heat into electrical power. So those are the kind of power sources people use. Craft that go way out in the solar system, it gets to the point where you'd have to have a huge solar panel array to catch enough sunlight to generate very much power. So far, that's only worked out as far as Jupiter. Beyond that, you've got to have nuclear power. What other questions here in the room before I go to the online audience?
I was just wondering if you could remind me.
Come on up here.
Oh, thank you.
Trying to include the online audience,
There you go.
right?
Thank you. Well, my question is, what order did Janice Messer? What order all of these Martian missions were in? Is it InSight, Perseverance, Curiosity, or Curiosity? And which was first? I think Curiosity.
Well, we've had quite a number of
Jeopardy.
Just
Yeah, this is like,
those three. I mean, no.
among those three,
Among the three that you mentioned.
right?
Pardon?
Curiosity, InSight, Perseverance.
Yeah.
Thank
Jeff
you.
McCloud was
but
saying-
then
Again, I'm trying to keep the online audience in on what we're saying.
Sure, sure.
Jeff McCloud says, and I think he's right. Among those three, it was first Curiosity, then InSight, now Perseverance, although Curiosity is still working too, because it's also nuclear powered.
Thank you.
Did you have something else to know with that?
Nope.
before that, it was Spirit and Opportunity and the Sojourner and
Yeah, there were earlier
Surveyor was
smaller,
an orbiter, right?
I can't remember if Surveyor was an orbiter or not. Yeah, it sounded like an orbiter. There was Spirit, there was Opportunity, and wasn't there a real little one? Sojourner. Before that, those early three rovers were all solar cell powered.
And then there was the Beagle probe, which turned from being a polar lander to being an impact test.
Yeah, the polar lander, Jonathan is reminding us, didn't land very gently. There was a incorrect conversion from metric between metric and
Yeah.
English units. Not good.
One of the most expensive unit errors in
Yeah, quite an error,
public eye.
an expensive error in unit conversions or lack thereof.
That was for an orbiter.
No, that was only
No.
it was
It was a lander.
Mars polar lander.
Any other questions here in the room? Okay, any questions online?
Sure, I have one. So this goes back to 2017, and I just recently saw some more online stories about it. But this goes back to, again, 2017. That large piece of rock that came into the solar system. I'm not sure if I'm saying this correctly, but I think they call it like a Oumuamua or something like that.
David, you are in the right place for that. I will give that answer in about 30 minutes.
Could you guys
So
hear what Jonathan was
was
saying?
that really just a hunk of rock, or was that a space alien ship?
We'll talk about it.
Yeah,
With pictures.
Jonathan, he's going to show us the aliens. So that was obviously a planted question by Jonathan. Any other questions online?
Yeah, I got a question. It's more associated with our observatory, and I understand that we got a imaging camera for that to be used out there, and if so, has it been used yet, and on what kind of objects?
Riyadh or
Yeah.
Jeff?
Yeah, we don't have, I mean, what we have is a very small camera. I forget what it's called now, but it has its own little screen and so on. So it's not a, true camera like what you have, Doug. Not a real astrophotography type of camera. It's more almost like a digital eyepiece with its own screen.
Oh,
We
okay.
are in the process of maybe eventually purchasing something that we would be able to use. And of course, I'm looking forward to talking to people like yourself and maybe getting recommendations on what to consider.
Well, the one thing I thought you guys were going to do was get a planetary camera because of the fact that the planets have been in good shape this last year in terms of positioning right now. Although they're starting to move to the west again. So getting a planetary one with that 8-inch refractor would be, I would think the first step. And those planetary cameras are not real expensive. So that might be a thought.
Yeah, absolutely. If you have some recommendations, you could email me which models and I'll take a look at that. Thank you.
Okay. Any other questions? I think this is interesting. It's interesting that.
Hey, Riyadh?
Yes.
So if you need to purchase something,
Yeah. Okay. Yeah, absolutely. I know the rules. Anything over $100, we need to vote on it. So.
Okay. Yes, Laura.
Yeah, Victor's there twice.
Well, it looks like Victor is maybe trying to say something, or maybe he just lost the connection to one of his devices.
Yeah, Victor Mansky seems to be showing up twice and
Yeah. I had some connection issues with my computer, so I quickly connected my cell phone. Don't worry, there isn't two of me, only one.
Looks like we have some questions in the chat, maybe. If you.
let me figure out how to find chat. Here's chat. Okay, which
no, there's no.
Maybe not questions, comments.
Okay, people are interested in where people might be going to the eclipse. Okay. I don't know how to respond to that kind of thing. What did I just do? Oh no. Where did everybody go?
Click on the Zoom icon down at the bottom. Right click on it.
Right click on it.
Maybe not. Click on Doug.
Click on Doug.
Yeah, that's always. Oh, click the up arrow. Oh no! Click the green, the green arrow. There we go.
How do I get out of chat? The X?
Click on chat again.
All right, I'm not going to touch chat because I'm afraid of what might happen.
There were no questions for you.
Okay, I have an astronomy question to entertain you with. It's not my question. I was at an astronomy camp in Canada about 20 years ago. It's called Starfest, really big astronomy camp. And there was a speaker, I don't remember who he was, but this speaker had an astronomy radio program in Canada, okay? And at one point he said an eclipse was coming. I guess the one in Western Canada, like 30 or 40 years ago or whatever. So on his radio program, he was talking about this upcoming eclipse. And he stressed to the audience how dangerous it was to look at the eclipse with just your eye, right? Or with binoculars or a telescope or stuff like that without proper protection. And he overstressed it, I guess, because it was a call-in program. And this lady called in, he said, she called in to his program. And she said, if this eclipse is so dangerous, why are they having it?
We should have it at night.
Yeah, they should have it at night.
That's similar to the deer crossing sign.
What deer crossing sign?
Yeah, why did they put it there where the deer will cross in front of us?
Okay, so much for astronomy questions. I thought that was kind of enjoyable. Do we have any observing reports or astrophotos to show? Or has it been too cold for everybody?
Well, I haven't been in a meeting in a while. I haven't done much in the last month or two, but I could probably share something from the last 6 months.
Well, that sounds good.
Okay, give me a second here. Continue on while I set it up.
Okay.
I've seen a lot of, a number of very nice.
Come up here.
Come
up here. I'm dragging Jim Shedlowski up. He's limping up.
Yes. Hobbling.
Hobbling up.
I've seen a number of very nice pictures, solar pictures of the sun, taken with this new C-Star S50, I think it is. My son, I kind of mentioned it to him a couple weeks or a month ago, and he bought one. And the next day after he got it, he has a wonderful picture of the sun. And just yesterday, I got another one from a friend, another astronomy friend of mine, who did had the same experience. He finally got a break in the clouds after 2 weeks getting this thing and set it up outside. And he said he just had to punch a couple buttons. It aligned itself, found the sun, and it took a great picture showing about 7 or 8 sunspots on it. So that's it.
Does it do nighttime photography too?
I'm sorry?
Does it do nighttime photography?
Oh, yeah, yeah. My son has got.
Repeat the question.
Question from Jonathan, does it do nighttime photography too? Yes, it does, of deep sky objects. It's not very good for planetary because of the focal length of the telescope, but my son had just a wonderful picture of the Rosetta Nebula that I could share with anybody at some future time, and maybe an email or something. But it's an amazing thing for $499. So
okay. How big is that thing?
It packs up.
Show them.
Oh, yeah, it packs up, and it comes with its own carrying case, which is about the size of a lunch bucket. A C-Star S50. It's a modern. It's a completely intelligent telescope.
How big what's the aperture of the telescope?
I think it's
50 millimeters.
I think 4 inches, isn't it?
50 millimeter.
I'm sorry?
50 millimeter.
50 millimeter. Okay.
That's
And
really
SEE star.
Yeah. SEE Star S50. It's made for people who are interested in astrophotography but have never done any of it.
S50 probably means 50 millimeter diameter.
There you go. That's probably it.
Yep,
Hey,
I know a couple of people have got one and they're having a ball with it.
Yeah. For $500.
Yep.
Of course, you probably saw the announcement last week where Celestron has decided they're going to make one of them too. Only they have a much larger, I think, a 6-inch telescope built into it, and they want $4,000.
Oh dear. No, I'm sure some people buy it.
In 10 years, we'll be able to get a scope with a computer.
It's true.
Well,
You'll have to build it yourself.
Save the money.
at the computer in Las Vegas, CES, last week, they announced 4 new electronic telescopes.
Okay, thank you.
So, thank you.
Where's Gary Ross when we need him?
Where's Gary Ross when we need him?
I'm ready.
Okay, Doug, you take the floor, please. Wow,
So I just got 3 slides to show you. This is the fireworks galaxy, NGC 6946, which I took in September at the Great Lakes Stargaze. And it worked out pretty good. 50 frames at 5 minutes each, stacked.
Very nice.
Over the last couple of years, I've been taking the Iris Nebula at various focal lengths and exposures. And so this goes all the way from a 300 millimeter, 735 millimeter, and 2000 millimeter focal lengths, just to compare.
Very, very interesting.
Is that with the same camera?
Yeah, same camera, but 3 different focal lengths and slightly different exposures between this one and this one.
Wow.
And then these were taken in November 18th and 19th. 3 comets that I worked on, and M78 and NGC 660. So that was in fact, this is probably the last time I had the observatory open. It was back in November. I may have had it open in December, but I don't remember at the moment.
Very nice.
And that's what I have to show.
Thank you very much.
Let's see here.
Lots of appreciation here. Okay, so it's time for a snack break. I hope all you guys at home have something to snack on. We have a few goodies here too. How about we're back for our main speaker, Jonathan Kade, at 8:05. See you then.
Okie doke.
Yeah, you can bring him down.
Charles, right?
Yes.
You familiar with the man in the chair? Every like superhero or Bond agent has in the chair. Cracked into the main frame. What you got going on?
Oh, I could have. You think this is the piece of music? Oh my God! Right and left screen. And these things, and I feel like I'm working maybe like an in the chair. Got all this stuff going. Works for me. Got my spreadsheet here, man here. See, I founded a festival in 2002, so I deal with clients and I got to sell them stuff and I got to communicate with them. I got to move on a map and I got to keep around the map. Space will worth more money. So as I get more money, yeah. So that's what I do, and I love it.
That price includes.
In fact, it'd be nice if I had done this. It'd be really cool. I don't know how much I could pay you to set up the moon lander. Like I would pay you or get a sponsor to pay you to have that as an interactive thing yeah, I could probably get some decent funding. One of these dispensaries,
I'll do it.
We do something, be like the far out display presented to you by Stizzy or something.
About getting in, don't do it.
I wish I could get already mentioned the Lottery Festival, so I got experience and,
This is a.
yeah, it crossed my mind for sure. I didn't want to say nothing.
Yeah, when you write, our vision, it really, it's fun, it doesn't matter if you like.
There will be some people on some medication there for sure.
Yeah.
And I think it'd be a really
That
fun
really,
thing.
makes the experience all the more realistic.
I think you would have a line, which I think would be really cool, and the dispensary would love that, you know, a line
Yeah.
to see something that they had something to do with. It involves some press ahead of
Well,
time.
when
to let people
in the
know.
year is it?
It's Saturday, April 1st, so
April
it's
1st.
a little crazy with the weather. We'd have to maybe have a cancellation plan. You know, there's other events that are indoors.
Well, she's currently immovable, so I gotta get her back together, but, it sounds like I got out.
That sounds like something interesting. If I can help
I thought they club, like I have Detroit Dog Rescue, they're gonna be there. It's a great place to train like that internet stuff.
You don't have to be. Well, first he's saying it's Monday.
It's Saturday, April 6th. It's the first
April
Saturday
6th.
in April every year.
But,
Yeah,
wait, April 6th, I'm not gonna be in town.
No? All right.
It's literally-
I plan on driving on Sunday. I do the Buffalo.
My son.
That's amazing. Other years, it's not Saturday, April 1st, and we won't have another. That's really 45 years.
I think the next 45 years.
Yeah, yeah, I've been doing it for 22 years now, so there will be a next one.
Good. Yeah, no, absolutely.
I thought they'd be so beautiful. My girlfriend's not going, she's like, thinks I'm crazy driving a Buffalo on a Sunday. I usually take off till Monday, I do that festival, I do so much walking,
Yeah.
probably do 50 miles walking at that festival. And, yeah, I'll see if I can do it, if I don't feel like it on that Sunday, I'm not going to. Why do you think they put the stay there?
The partial spine, and that's all it's gonna be, like, the best it's gonna be is a partial. I'll set up for a partial, I'm not too snobby, but if there's a totality, I'm within a compliment,
I just hit
a partial is slightly bigger.
Well, I've looked on a map and there's this place, Findlay, Ohio, it's up to 75 a little bit. Looks like the smallest town ever.
Yeah.
I didn't know if they have a hotel, but I would look into that soon.
Yeah, you can just drive, if you get on the path. I recommend Fred
They
Aspen.
get police there.
Having the day of, if you need to go down the country road, you've got a detailed road atlas. It's the path.
Fred Aspen Atlas.
You look up.
How many are you getting?
Road atlas.
One for the kitchen, one for your work, one for my work, one for.
You get it for 20.
And Janice, how do you do? He might know.
I don't want to say, I think you started attending in like 2012,
Some astronomy stuff.
I think your past 10-year anniversary.
No, I'm an amateur. I can't.
I was gonna buy it. Check it.
I've been.
Just need to know the dates. For last Saturday.
Jonathan, what should we do with this thing? Working, I'm going to this one. I think there's other ways for this club that would be.
I'm still
Saturday, because the
I
problem
was
is
actually.
it's the day of.
8.5
This part.
8.5 years there.
You gotta know what's going on.
I'm fine.
Trust what's on the. As far as like the.
Bullet joints. I call it.
So then you're trying to compare that to the road atlas to figure out where you are. And you end up not quite where you want to be. You know what I mean? Because you got to know, right? You got to just put you. You don't know where.
You guys figured out your problem
into a situation.
Yeah.
Playing the odds with the weather, is that
Yeah, we don't want to miss it, but we also have a lot of friends in Australia. So.
nice place to sit?
Yeah, we figure it'll be a good place. I have some friends in Dallas.
I'm gonna get that,
A lot of friends in Austin, and I have friends who. My hope is that everybody is going to get it. We're actually only doing, I think it's really expensive.
Yeah.
So we're only looking for like
John's
3
dad bought a
days.
fishing cottage there back in like. During the pandemic, we bought a lot of land.
Not that I know of, although somebody.
Friend from the generation.
It's like my friends are music. At least one musician is attending.
In 2022, Jason.
Which I haven't picked up a guitar in 2 years, so.
I
was working on,
which has a house on it.
I was working on the Ukrainian national.
With a cement pad in front of it. He bought that. So now we have 3-bedroom
So I was working on that.
house. It's not large, but it doesn't.
My instructor,
Or
my instructor had life intervened in session. And my, and the other instructors
got me
required me to every Saturday, and I can't do every Saturday. It's like halfway between a loop and
So we bought a second one.
So
It's adjacent to the parcels that
it's
we
got
bought.
13 spaces.
It's right on the river with a good
And I think
sunrise.
46
And it has a barn.
It's a
That
monster.
pad out front, so you just roll telescope.
So that's why you, and these.
Yeah. And we've got
Thing is that half of the players are 13-year-olds.
telescope. up
Yeah,
there.
so there's this massive instrument.
John
for
Kelly,
13-year-olds.
Russ passed away, and we bought his largest telescope.
That's how it seems to me. I mean, in terms of. Yeah, I think it's. I struggle to get my arms around it.
So we've got, oh my God.
That's because you're like a 13-year-old.
Yeah, it's just, we didn't have to build it, we didn't have to build it and roll off. Right. Serving, then go to bed. Yeah. So it's a game changer, so it's,
I'm taking vacation.
unfortunately,
Board stuff for one.
a lot, an increasing number of our neighbors have been very bad about these spikes. Yeah.
I'm just, I have to go. Because we bought a second house. The first cottage.
Yeah, so it should be, incredibly.
Because it was next to our field that we're trying to.
But the love life has gotten worse.
There's
There's
this great boulevard with
And now, here,
with a.
3 miles away from Naked on State Park, which is our sky system.
It's weird. It's supposed to be like a driveway for the car. But the driveway for the house doesn't connect to it. Because, well, the water line is supposed to be. The driveway and the
politics.
So if you drive over it, you're gonna end up getting.
Yeah. 4 hours. Like 3.5 hours if there's no traffic.
But yeah, so we have the 20. We have the 20.
No oxygen. So realistically.
24 inches in
Yeah.
So now I have.
Yeah.
I have 3 sets of, well, I don't have gutters in my here. But it's just.
Civic stuff is going to be up there for the New Year's, paper drop. There in the park. We're sick, we got a hospital, so we couldn't make it. Just trying to become part of the fabric. Yeah. Jonathan's there for 30 years now.
And I'm like, I'm the only one. My brother was there.
That's a picture.
Taking care of family
People that, yeah.
There's like we have
Oh yeah, no, it's yeah, I mean Dearborn skies are terrible. Absolutely. See, an absolutely perfect moonless night in Dearborn. You might see her magnitude stars. Only.
Yeah, as you can tell, it's every me there. And so the whole place is going. It's right.
This year we need to reassemble the telescope because it's currently in storage.
Just more.
Reassemble the telescope, observing. Jonathan had some shoulder issues last year, so he needs to assemble the telescope. It really is a two-person job. I had some help, he had some help. It wasn't easy. So we'd like people to,
it's like if somebody else buys it, you're probably gonna have like. So I told Diane if it ever goes up for sale, we should buy it. And then it went up for sale like the year after we bought it. So it's like, well, I wasn't planning on spending that this year, but
yeah.
If we don't buy it, somebody else is going to do it. And who knows what we're going to do. Yeah, it was affordable, and our house is almost paid off. Yeah, so everything is kind of all of our other debts are kind of going to the wayside. So now the mortgage that we took out on that is like 6.5%, which is I hate it.
Yeah, we have to be able to, yeah. Yeah, because the house is here.
So this is where the observatory is.
Full board is here.
So we
The
have
septic
this.
field is there, so we can go there. But
Yeah,
then
well,
the
the observatory is that's where you have.
We're on the river. We're on the black. We have a river. We're in the Black River. So that's our observatory. That's our bench. You see this sort of line? We own this thing. So that's a house that used to live there like. But no, I mean, we've had issues. They didn't like the fact that we were keeping a lot of their butterflies and pollinators and grow the writing. Yeah, I called the police on them, it was bad. So yeah, so this whole historical area to the railroad tracks. So we've got 3 apple trees. Produced pretty good apples.
Yeah.
Thank you.
Again.
What's that?
You had like that.
Yeah, it's a double parcel that people can camp on. Wow.
Spicy and sour.
Do
you have any
What's that? No, it's a very economically depressed area. There's a B&B that's like 5 miles away, and that's about it. What's the nearest city? Black River. It's not a city. Alpina's 30 minutes away. Yeah. Yeah, but there's nothing within like a 15-mile radius.
But Oscoda,
Well, that's why it started.
I mean, Oscoda's 30 minutes south and Alpina's 30 minutes.
We're getting away there.
So we've got a really good standard milk feed going, and
We had like a plants. So I think we had about 60 in Dearborn and then 100.
wow.
This is a great. Yeah, my
And we just keep coming back.
we never really go to the place.
They're incredible.
We go to.
So that's the reason that we want to.
We go there.
Part of the community up there more. So we have our two houses are right in a triangle with the township park.
I mean,
so the township raised flower bed.
I inherited it because somebody had. My sister in Virginia.
The same weekend, they're crazy. Destroyed our yard.
Stay there.
The two residents ripped everything the township garden, put in geranium.
Going up.
Because they said they wanted to spray it for the Labor Day parade, which they wanted geranium.
I would be in the office every week, so Thursday night.
That's the problem. It's a very conservative area. This is, yeah. So it's very poor, it's very conservative. So
Yeah.
Pioneer Garden here, which is built by somebody who says had some health issues and can't maintain it. But like somebody like made this thing happen, and then other people came around when she was out of town. Like, all right, let's wreck it.
You can't even.
So yeah, we have. Right. So it's up to us to like participate in life up there.
It was never good, but at the same
back.
With all the businesses are putting it out. Right, yes. Well, and we used to have.
Yeah, so it's just an ongoing.
Here.
Yeah. Oh, we just
You guys, I'm glad everybody's enjoying each other's company. It's taking some effort on this end to get people in their seats and stuff. So tonight, it is my pleasure to introduce Jonathan Kade, who, for anybody who's been around this organization very long, he doesn't really need an introduction. But for those who are kind of new, he has been on the board of this organization for most years since 2008, including being our president. As a part-time resident of Black River, Michigan. Where is Black River?
It's right here.
30 minutes south of Alpena.
Oh, yeah.
Okay. Up a ways.
On the sunny side.
Sunrise.
He is in love with Michigan's sunrise side. I never heard it called that before. And it's still wonderful skies. He and former Warren Club president Diane Hall, take a bow, are in the process of starting Dark Skies Elkona, an organization aimed at promoting and protecting the skies of Elkona County and the sunrise side in general. He is a devotee of patience, serendipity, and stochastic processes.
I wrote that a long time ago. Dale just reused that 2 years ago.
And his presentation tonight apparently has some relationship with those qualities. He's going to be speaking on interstellar objects I have known. Sounds intriguing.
Thank you, Dr. Burton. All right. Sort of pulling my notes off the edge here. All right. Hopefully you didn't get any spoilers there. All right. Can everybody see and hear me okay on the Zoom? I guess I can't see the Zoom anymore, so blink twice if okay. If anyone is on the Zoom or can otherwise check on the status of it.
We hear you.
All right, good. All right, so now I have to say, yes, sir.
Ask everybody to make sure they're muted.
Yes, please make sure. I think Dale is keeping the mute in place. Virtual Dale, not physical Dale. But so I should say it is interstellar objects I have sort of known. I have not seen any of these with my own eyes. So, but I would like to someday. All right, so to start with, to sort of understand what we're talking about, we have to first understand what the word interstellar means. So to sort of get us there, I thought we would tour the solar system first. So here, this is not purely to scale, but it gives you some idea of how close we are to the sun compared to the rest of the solar system.
Use the mouse to make.
Oh yeah, that's a good point.
Need to share the screen.
Oh. Sorry, it's
It's strange that I should have to tell him this. He's the expert.
I thought that would have happened already. All right.
I should be nice. Wonder if a mandatory class in high school nowadays. Miss that class. They're gonna get more than 3 or 4 years.
All right, we're gonna do it. All right, I think we're good. Are we good on the stream?
Yep.
We are.
Very good.
All right. All right. So sorry. So you didn't miss much. So just to show you, let me see if I can use this. So this isn't purely to scale, but it gives you some idea of the relative sizes of the objects and how close they are to the sun. So we're really close to the sun, but this is sort of what we think of as the solar system sort of by default. It's the sun and the planets, right? And Neptune goes out to 30 astronomical units. So an astronomical unit is the distance between the sun and the earth, because we're just that self-centered as humans. So if we take it out further, we get to the Kuiper belt, and that is the plane of comet of small objects of different kinds on the edges of the solar system, and they are on the same plane. They're all part of the same disk as the planets. And then you have you do have things like Pluto that is kind of tilted with regard to the rest of the solar system. If you go even further out, and sorry, so the Kuiper belt goes from 30 astronomical units, which is where Neptune is, which Neptune is the white line here, out to 55 astronomical units. As we go further and further out, the termination shock, which is where the sun's atmosphere, where all of the gases being pushed out by the energy of the sun, hits sort of the interstellar medium, the space that the whole solar system is speeding through. That is 120 astronomical units, so 4 times further than Neptune's orbit. And that's the outer edge of the Kuiper belt. And beyond that, there's this thing called the Oort cloud. And so the Oort cloud, you might know, is where a lot of the really weird comets that we see that come from, that only get close to the sun every 30,000 years. And they actually orbit the sun in a sphere. So the sort of the main solar system is a disk, and then the Oort cloud around the sun is a sphere of all of these comets.
Is the Oort cloud an ecliptic?
The Oort cloud is so the ecliptic is the ecliptic. So you might know, you might have heard of the ecliptic. The ecliptic is the plane of the zodiac. So that's where the sun and the moon and all the other planets orbit in. And that's that disk of the solar system. The Oort cloud is 360 degrees. It's a ball around the sun. And yep. And so the Oort cloud actually goes so far out, it's 10 to the 5th astronomical units, right? And Alpha Centauri is between 10 to the 5th and 10 to the 6th. So it's like 5 times 10 to the 5th astronomical units. So the sun's gravitational, and the Oort cloud basically is what the sun's gravitational influence is. So that's kind of the most distant thing that you could consider the solar system. The whole Oort cloud is moving with the sun with the same angular velocity through the galaxy, through the disk of the galaxy. And that you can think of that as the real solar system, depending on how you want to look at it. So what counts as the interstellar boundary? Is it when you get outside of the Kuiper belt? Is it the solar dynamic boundary where the sun's gases stop pushing outwards and the interstellar medium kind of meets that energy with the same force? Or is it the edge of the sun's gravitational sphere? And so to start with, I was going to talk about a couple of interstellar objects, or 4 interstellar objects that humans are responsible for by definition too. And those are objects that have gotten past both the Kuiper belt and past the heliopause, which is the sort of area where the sun's energy kind of meets the energy of the medium that we're moving through in the galaxy. So Voyager 2 was launched August 20th, 1977. Voyager 1 was launched September 5th. Yes, Voyager 1 was behind Voyager 2. And so they were both launched in 1977. You might have heard in the news that they left the solar system, and by some definitions they did. So they're the first 2 objects, man-made objects, to enter interstellar space. And so they got past the Kuiper Belt back in the 2010 or in the 2000s, and then in the 2010s they got past the helio sheath. And so this is kind of a diagram of where Voyager 1 was. So you can see the heliopause is here, and that's where the sun's energy stops pushing outwards, basically. And so Voyager 1, even though it launched second, it got there first on August 25th, 2012. Voyager 1 was pretty close behind. So this is kind of, this presentation keeps getting longer as more stuff keeps happening. So I'm gonna kind of speed through this, but through the different regions at the edge of the sun's dynamic environment. Voyager 2 reached interstellar space by that getting past the heliopause definition on November 5th, 2018. So 6.5 years after Voyager 1 did. So when will the Voyagers leave the solar system by the definition 3, which is getting past the Oort cloud? Does anyone have a guess? A very long time. Somebody put up a number. Just 2050, Laura says. All right. The answer is the year 32,000. So if we're still here, I would be really happy. But for me, the bigger question is, when are they going to come back? Sorry, this is, if you've seen Star Trek the motion picture, this is Voyager. So sorry if I spoiled the movies. Apologies to Gary Ross. But yeah, so you should, if you haven't seen Star Trek the motion picture, you should see it. Other probes going interstellar by definition 2, Pioneer 10 and 11 are going to get there eventually. Pioneer 10 is going to escape the heliopause around the year 2060. Pioneer 11 is going to get there around 2030, so in the next 10 years. And so this is kind of a top-down view. So you see Pioneer 10 is going out this way. And actually, so the reason that Pioneer 10, which launched earlier than any of them, is leaving so slowly is it didn't have the amount of, it didn't get to the same speeds that the Voyagers did. And also it's going out sort of the backside of the solar system instead of the short side of the solar system. So, yeah. And then New Horizons is going to be the next, and actually I think it's going to beat both of the Pioneers out. But New Horizons, you may recall, was the probe that was sent to Pluto to sort of study Pluto as a dynamic world for the first time. And so it is going to, oh no, so it's going to be after Pioneer 11. So 2043, mark your calendars. New Horizons is going to leave the heliopause then. And then can anyone think of any other things that might join these very fast, very far-flung probes on their journey out of the solar system? If you think about how they got to where they are, you might think of the answer. The boosters. So obviously, to get them to where they're going, they needed propulsion, and they don't have propulsion themselves. So eventually, most of the boosters that took them to the outer edge of the solar system are going to follow them out of the solar system as well. So space junk is going to be humanity's contribution to interstellar space. All right, so those are so far the man-made interstellar objects that exist. Now I wanted to talk about natural interstellar objects by definition 2. And if you remember what we've said so far, you're going to know the answer. And yes.
Do you call them natural if aliens sent them?
Well, we'll get to that. But yes, if non-humanity created, how about that? So Oort cloud comets by definition 2. That's why definition 2 is less exciting to me than definition 3, because there are literally millions and millions of Oort cloud comets. Maybe billions, maybe billions. because, you know, it doesn't have to be very big to count as a comet. It just has to have a bunch of ice. So you can talk about comets all you like, but let's talk about natural interstellar objects by definition 3. Stuff that came from outside the Oort cloud, from outside of the gravitational influence of the sun. Sorry, is there a question on the line? Okay, I think that was just somebody clearing their throat. All right. Sorry, definition 3. Let's go back to, let's look at the diagram again. So basically, so definition 1 is Neptune back here. Definition 2 is the heliopause right here. So about 100 astronomical units. And definition 3 is the edge of the Oort cloud, which is like basically 500,000 astronomical units. So everything we're going to be talking about from here on is from outside 500,000 astronomical units. So the first confirmed 100% certain natural interstellar object, maybe natural, we'll talk about that, was what was classified 1I. You know, we like to have comets be, you know, 36P if they're periodic or whatever. This is the first interstellar object, so it's 1I, and it's named Oumuamua. That is in the Hawaiian language. I call it the intergalactic thingamajig because we're not 100% sure exactly what it looks like. So this is a history of Oumuamua. So the initial reports were that Oumuamua was rotating extremely rapidly. It was 20 kilometers long by 20 kilometers in diameter by 54 kilometers long. And it was basically like one of Arthur C. Clarke's monoliths floating through space. And then they got better data, and then that kind of went out the window. So it got downgraded to kind of a space cigar. And then they collected more data this was all over the course of maybe a couple of weeks, and said, oh no, maybe it's a pancake. So this was from June 2018 that they had decided that maybe it was sort of pancake shaped. And then there's a lot of evidence against that too. And really all we're looking at is spectroscopy, so we can see kind of the color of it and the brightness from the different telescopes. Yes, Laura?
Where is it outside the Oort cloud, or it's coming in?
Right now it's still inside. It's still pretty close to the solar system. We'll see the orbital track pretty soon. So we don't know exactly what shape it is. It's pretty red. It's spinning really fast. And the reason that we know that is because we see the light curve and we can look at sort of the color of it. And so we can do spectroscopy on it, and we can sort of model the movements of it by watching how it brightens and dims over time. And so it had this really fast brightening and dimming cycle, so we know that it's rotating really fast. And so these sort of dots are from all the different observatories in the world. So the Hale telescope at Mount Palomar, the Herschel telescope in the Canary Islands, and then we had Pan-STARRS in there and Gemini and all kinds of other stuff. And the light curve also suggested that there was a lot of metal in it. So it looks kind of like probably something like an asteroid that we would see, like a metal asteroid in our solar system. Yes, Laura?
Does it have a trajectory?
It does. We're getting there. So as of now, the estimates for Oumuamua's size are a lot smaller, 800 feet by 100 feet by 100 feet. So basically around the size of the Empire State Building, which is big, but also not the size of like a Hawaiian island. So it's rotating probably, if their understanding of the shape of it is right, it's rotating every 55 hours, but also it's spinning like a badly thrown football, which hopefully we're not going to be seeing this weekend. So it's basically the ends are kind of tumbling every 9 hours, and then the whole thing is rotating every 55 hours. So people thought, well, maybe it's an interstellar comet initially, but it didn't show any signs initially of outgassing, and the colors made us think that it was probably rocky and metal. So it kind of got to interstellar, and then we noticed that the trajectory of it was kind of weird, and it was doing things that maybe it shouldn't be doing. So the comet idea came around. Some people suggested it might have been a chunk of a planet. Here's an artist's rendition of how that happened. Sorry, Gary, if you're watching this. More likely, it's probably a primordial leftover from the formation of some other solar system. There is a researcher who you're going to hear a lot about over the course of this presentation called Avi Loeb at Harvard. He really wanted it to be an alien spaceship or space station. There's no evidence of that. There's no radio signals, and nothing about the movement of it suggests that it's directed in any way. Yes, Dale?
Isn't he the guy who anything weird that turns up astronomical?
It's aliens.
Yes.
Just you wait, Dale. Everyone's ruining my stuff. Oh man. Okay. Anyway, so the funny thing is, so this book, Rendezvous with Rama, that was sort of the maybe what Avi Loeb read too many times as a kid, but it's about an alien space station that falls into the solar system and passes by Earth, and stuff happens. And the dimensions of the Rama object in the book are very similar to the initial reports of the size of Oumuamua. So that's what people were thinking initially. But it's not a space station. It's almost certainly a natural object of some kind. SETI and Green Bank both watched it for as long as they could, and there's no sign of any transmission. So who found Oumuamua? Well, a neighbor of ours, Rob Warwick, got his bachelor's and PhD from the University of Western Ontario in London, Ontario, which is just a couple of hours away. He is a postdoc fellow, or at the time he was a postdoc fellow at the University of Hawaii at Manoa. He discovered it on October 19th, 2017, and then went back through the data, and they found that they had recorded it on the 14th and 17th as well. It was discovered with the Pan-STARRS-1 telescope on top of Mount Haleakala on Maui. So John Blum, if you see this, thank you for sharing the island with us. Why is it called Oumuamua? As you can probably tell from how it sounds, it's Hawaiian. It's sort of a word for scout. The U sound means to reach out for. Mua is like first, and then you repeat it for emphasis. So it's like the reaching out thing that was really first. And it was chosen by the Pan-STARRS team with guidance from Hawaiians from the University of Hawaii at Hilo. So originally it was designated Comet 2017 U1. Then it was designated Asteroid 2017 U1. Then it was designated 1I. And the final name that we all settled on was 1I 2017 U1 Oumuamua. So to Laura's point, where did it come from and where is it going? So apparently it came from the area of Vega. Apparently it's going into the middle of the emptiness in the middle of the Great Square of Pegasus. So here is a sort of where it came from in the sky, or sorry, yeah, so on the top here, this is where it came from.
Was this in Vega?
Yeah, so that's the star Vega here.
Oh.
And so it kind of came in this spiraling motion from way up there, came through our solar system, and now it's going out through the bottom of the solar system into the Great Square of Pegasus.
That's appearance from Earth. So
This is, yeah, this is the appearance from Earth.
this is a natural mathematical beauty.
Yes, yep.
Isn't that amazing?
It's pretty cool. It's like, this is the same kind of, if you've seen a solar analemma where the sun makes a figure 8 in the sky, if you take a photo every day from the same spot on Earth, the sun makes a figure 8 in the sky. This is the same sort of thing. So this is from one point on Earth when Oumuamua is in the sky. This is the track that it would have made in the sky if you were looking at the same sky every day. I mean, yes and no. So, well, and here's the other thing. Oumuamua left wherever it left a long time ago. So when it left from where Vega is, Vega wasn't there. Because the whole galaxy is revolving, for one thing. All of the stars have proper motion. They're all kind of moving in different directions inside the galaxy. So we don't know what star system it came from, and we don't know what's going to be. So it's going out kind of through the bottom of the galaxy. There's not much down there. If you look at the Great Square of Pegasus, there's nothing in it. That's why it looks like a square. So that's kind of the bottom, the window out the bottom of the galaxy. So who knows where it's going to end up? I mean, maybe in trillions of years it could leave the galaxy.
Can you offer a little bit more information on that? That's just beautiful. That path there.
This is a kind of path, so you will never see a path for any other object except an interstellar object like this, because a comet is going to be coming from the Oort cloud. It's going to come down and go out. It's not going to be doing this spiraling thing in the same way that Oumuamua did. And so this shows kind of its brief sojourn in our solar system. So this is so it came sort of into near the orbit of Mars on July 29th of 2017, passed close to the sun. It passed 0.255 astronomical units from the sun, 17% closer than Mercury. And it actually got within 0.1, it got to 0.16 astronomical units from Earth. So pretty close to Earth. If we had a probe ready to go, we might have been able to see it close up, but we didn't. And then it was back outside the orbit of Mars by October 28th. And that was before it was recovered.
The sun didn't burn it up.
No, it didn't get close enough. And so that's one reason we don't think it's a comet, because it did pass really close to the sun. Some comets would get torn apart, and it didn't really show much sign. It acted like a rigid body. It's going to take 20,000 years for it to leave the solar system by definition 3. Yes. I have that written down here somewhere, but I might have to look it up and get back to you, because I think I'm not going to find it at this point, and I still have a number of things to talk about. We might there's a possibility it will still come up. So just how do you know that something's going to leave the solar system, right? So orbits are represented as ellipses or as hyperbolas. So an ellipse with an eccentricity, which is like how squashed it is, of 0 is a perfect circle. So this gray line here is a perfect circle. So that's 0. All of the natural bodies in the inner solar system and the Kuiper belt have orbital eccentricities between 0 and 1. So that means that in fact, everything in the Oort cloud too, what that means is that it's not going to escape the solar system. It's going to keep orbiting the sun. As soon as you hit an eccentricity of 1, that means that it's a parabolic orbit. It's not going to stay orbiting. It's going to reach escape velocity. And once you get beyond 1, it's a hyperbolic orbit. And that means that it's in the context of our solar system, it means that it didn't come from the Oort cloud. Like Jupiter can yank something out of the Oort cloud and send it on a parabolic orbit and shoot it out of the solar system, but it's not going to, at least as far as I know, it's not going to accelerate it enough to put it into a hyperbolic orbit. So the only object previously observed to have a hyperbolic orbit was comet C 1980 E1. And that only had an eccentricity very slightly more than 1, whereas Oumuamua's was 1.2, so way beyond 1.
87.3 kilometers a second.
87.3 kilometers per second is the speed Oumuamua is going through space. All right, so how do we know its orbit? Well, as usual, it's Kepler's fault. So Kepler's laws are all gravitationally, he said planets, but all gravitationally bound orbits, objects move in elliptical orbits with the sun at one focus. A line that connects a planet to the sun sweeps out equal area and equal time. So you got to do your integrals there. And the square of the period of any planet is proportional to the cube of the semi-major axis of its orbit. And so what that basically means is you get to do a lot of conic sections, you get to do a lot of calculations, you get to do a lot of calculus. And so you can basically, if you know the position of an object in a gravitational reference frame over a certain period of time, over a certain period of space, you can figure out how fast it's going, where it came from, and where it's going to. I'm not gonna, it could get pretty deep here, and I'm not really qualified to do that, but this is called, so we still basically use the Gauss's method. Gauss invented it supposedly as a before he was 20. He used it to calculate where the asteroid Ceres was going to be. And it took him over 100 hours of calculations longhand to figure out where Ceres was going to be. And then once he had gotten used to it, it only took him 10 hours to calculate the position of Vesta. And he got to the point where he was calculating comets in an hour. So this is a well-established method of doing things. The problem was they were getting these observations of this object and they didn't believe them. So they tried 2 different elliptical orbits because they were just they didn't want to immediately jump to the conclusion that this was something super weird. And then they gave up and they said, this doesn't fit to an ellipse, it has to be a hyperbolic object. So that's sort of how they determined that it just has to be interstellar. This should be playing. See, this is why we do, there we go. Did it just decide to not play again? Oh no, I have to, there we go. So this is a visualization of Oumuamua's trip through the inner solar system. So if it were just if it were just an asteroid going through space without anything coming off of it, then it should have been 25,000 miles away from where it actually was on January 2nd, 2018. So that suggests that maybe it was a comet. There was some force coming from it that was not being represented by just strict Newtonian mechanics. And so people are thinking that, and so a normal comet wouldn't actually be that far off. So the thought is now that it actually had like liquid, or it had frozen hydrogen on it. And that's what has contributed to the idea that it was some primordial object formed very early in the life of the solar system, or maybe even early in the life of the galaxy, because it has all this frozen hydrogen on it that isn't all that common to find. All right, so the second interstellar object, Comet Borisov. So what is Comet Borisov? Well, people said it looks like a comet. It was a comet. It looked like a comet. So here are the first detection frames from Crimean amateur astronomer Gennady Borisov from August 30th, 2019. Here are some nice astrophotos from 2019, passing by a distant background spiral galaxy whose name is just a bunch of numbers. Comet Borisov was about 203 million miles from Earth in this exposure. And this actually came from Hubble. And here's a video of, this is from Hubble as well. So this is tracking Borisov through the sky. It has a high carbon monoxide to water ratio. So it came from whatever solar system it came from. It was probably in conditions similar to the edges of the Kuiper Belt or even the Oort cloud. And it's possible there's some of the chemical analysis suggests that it might have even formed around a red dwarf because it formed someplace super cold. Janice?
If you could repeat that, something about a red dwarf?
Yeah, so basically because of the ratio of carbon monoxide to water ice, the thought is that it formed someplace much, much colder than our inner solar system or even the inner Kuiper Belt. And so one of the things that where that would happen is in a red dwarf where the star never really, it didn't get far enough on the main sequence that it sort of heated up the environment. So the coma around Comet Borisov was 14 times the size of Earth, which was pretty cool. So who found Comet Borisov? Gennady Borisov of Ukraine, born in Kramatorsk, which is now the provisional capital of Donetsk Oblast in Ukraine. He has had for 25 years a personal observatory in southern Crimea, which, as you may know, is not a good place to be right now. And so he actually works. He started working with the University of Moscow, so it's not a good place to be. But he's discovered 9 comets, or at least by 2019, he had discovered 9 comets and discovered 4 or 5 different near-Earth objects. And he built all of his own telescopes and fabricated all of them. Yeah. And so his day job working for the university is not to observe, it's to make equipment and maintain the observatory, but then he is also a dedicated amateur astronomer. Yeah, and so this is him with his personal telescope that he made and where his observatory is. And so, and it's just really funny that Comet Borisov hit us just after Oumuamua did. After years of never seeing one of these things, we got 2, one after the other. So Comet Borisov is a comet. It didn't come as close as Oumuamua did. In general, it's not quite as interesting as Oumuamua. But here's the 2 of them together moving through space. So you can see, and Oumuamua also came close to the sun, so it got a slingshot effect that Borisov did.
Hey, Jonathan.
Yes, sir.
How different the path of Oumuamua is here compared to the earlier spot. The golden circles coming.
Well, but that was over 10,000 years. So this is just over a couple of months.
Can you repeat your question?
So Mike O'Dowd said that the track of Oumuamua here doesn't look like the spiral thing we were looking at earlier, but the spiral thing was kind of looking back 10,000 years and looking forward 10,000 years. So yes, Dale.
Wasn't the earlier spiral thing as it would have been seen from the Earth?
And also as it would have been seen from the Earth.
Versus this is how it would have observed from a stationary place outside of our solar system.
Yep.
Repeat, please.
So Dale said also that was the earlier slide we looked at was what it would look like from Earth, whereas this is kind of looking from outside the inner solar system or outside the orbit of Pluto even. Sorry, was there a question on the Zoom? All right, moving ahead. So this is kind of a top down, so you can see it just got deflected a little bit top down. So unlike Oumuamua, we do know where Borisov came from. there's a lot of evidence to suggest that it came from a star known as Kruger 60, which is comparatively close by. So this one is a lot less mysterious than the other one. And that is, yeah, so that at least we know that it passed by that star 1 million years ago. Yes, that's a binary star. Now, so those are the two that have come and gone. But the question is, do they always leave? Or will they come to us? So hopefully not like that. I have no evidence to suggest that the Yucatan, the Chicxulub meteor was an interstellar object, but it would be cool if it was. So the answer we are increasingly sure is no. Sometimes interstellar objects come to rest on the Earth itself. So on July 28th, 2006 in Karachay, Cherkessia, there was the supposed discovery of an intergalactic meteor particle by supposedly a 6-inch telescope. No, sorry, 6-meter telescope. Okay, yeah, sorry, it's very small on my screen. But that was from the Russian Academy of Sciences reported that, and their evidence was basically based on the chemical signature of it and the energy, the way that the emission lines were showing up, that it had a certain amount of energy coming in, and thus it had to have been interstellar. This one, it was just one observation. There's not a whole lot of evidence to support it. So that one was kind of, not a whole lot of people believe that one was. More recently, there are two that have gotten more support from an unexpected source. So the first one was CNEOS 2014-0108, aka IM1. And so this is so we're back to Avi Loeb again. So this is Papua New Guinea. And you can see, so this is the main part of Papua New Guinea. Oh, sorry, I need to turn my pointer on again. This is the main part. This is the whole of Papua New Guinea. And so you can see it's this Manus Island up here that it exploded near. And so this is just north of Australia. Yes, Janice.
I'm sorry, so you're saying it exploded in the air before it did?
Correct. Yep. So this was an airburst meteor. It would have been a great thing to see if anyone was here, but nobody was, because it's like 100 miles from Manus Island, and there's very few people who live on Manus Island anyway. So these are the two discoverers of this object. On top, Amir Siraj of Harvard and his professor Avi Loeb. And this letter here is, as I said, it's from an unexpected source. So the Department of Defense, which monitors for use of weaponry in the atmosphere, detected this object and analyzed it. And of course, they're spending a lot of money to do analysis that a lot of other things don't get that much money. And so they basically confirmed. So Loeb and Siraj asked for any evidence, any observations they had of this object, and they confirmed, yes, these are the sort of orbital circumstances of the object. It was half a ton. It was 60 kilometers per second heliocentric speed and asymptotic speed entering the Earth of 42 kilometers per second. So going super fast. And so this changed since the last time I gave this presentation. The Galileo project team from Harvard, so Avi Loeb and company, got $1.5 million to do an expedition to dredge the ocean floor north of Papua New Guinea, and they found cosmic spherules. So these spherules definitely came from a meteor. They found, I think they found several hundred of them. Now, these are all microscopic, so these are sub-millimeter objects. But they believe that they all came from this object that exploded and vaporized into a bunch of tiny droplets. Their estimate is that probably the biggest, from the way it exploded and the material strength of the object, probably the biggest remnant of the whole half-ton meteor was probably around 1 millimeter. So the biggest thing they can find is going to be like 1 millimeter. So they had been dredging for 7 days and they hadn't found anything. All they were just, and remember, there's a bunch of volcanoes here. This is the Rim of Fire. So the ocean floor is just completely covered in volcanic ash. And so all they're getting is buckets of volcanic ash. And then they started filtering and sluicing it through different size mesh filters. And eventually they found some things that were shiny and they put it under a microscope and said, that's a spheroid. And so that's pretty exciting. The composition analysis is 84% iron, 8% silicon, 4% magnesium, 2% titanium, and trace elements. So titanium is not something we see a lot in our meteors that come from our solar system. Yeah, so less than a milligram. Uh-oh. It's not letting me get past this. And so this diagram shows sort of the strength required to explode a meteor. So sort of the baseline here is what a stony meteorite would airburst at. The green line here is where an iron meteorite would burst at. And the observations of this meteor show a flare at this ram pressure. So this is like the degree to which it's compressing the atmosphere. So there was a big spike here, and then a big spike here, and then it blew up. So it's whatever it was super, super dense and super tough. And as Dale Parton was saying, Avi Loeb is somewhat infamous for whenever something happens, saying that it's probably aliens. So his initial speculation was that it has to be an engineered alloy from some other technological civilization. It can't have been natural. So they are planning to go back this year. One asterisk in the proceedings is that they didn't get permits from the Papua New Guinea government to do the research. Technically, they didn't break any laws, but also they didn't show very much respect to the host country, so they're still kind of mad at them. So it's not clear whether they'll do anything to try to stop them, but they didn't ask the right people to sign pieces of paper, and now those people are mad at them. So we'll see, but it could be by this summer they will be back there. And there was another one of these objects as well that fell near Portugal in 2017, and it was over the Atlantic Ocean near Portugal. Basically, because the area around Papua New Guinea is a little bit quieter in terms of just ocean dynamics, they wanted to start there. But the idea is after they get good at sampling the ocean floor for meteor particles, I still find it hard to believe that they found anything. But could they have been from some other meteors? It just seems it seems like a literal needle in a haystack, or a needle inside, a New York City sized bale of hay. I don't know, but they're going to do it again off the coast of Portugal. This was a much, much bigger meteor. This was 6.3 tons, but about the same heliocentric speed. So a little bit slower, but still way faster than anything that would normally come in from a solar system object. All right. Another discovery, a somewhat recent discovery. So this was discovered in 2014. This object is known as Ka'epauka Awela, which is also Hawaiian, also discovered by Pan-STARRS. And it is the strangest thing. So this is an asteroid, a minor planet. It orbits in a 1-to-1 resonance with Jupiter. So when Jupiter is here in its orbit, this is here in its orbit. And so the orbits cross, but they will never be in the same place at the same time. And this object orbits retrograde to everything else in the solar system. So whatever it is, it did not form with the rest of the solar system bodies. And pretty much the only way anyone has been able to figure out to make an object go into that kind of retrograde orbit with a 1-to-1 resonance with Jupiter is that it was probably an interstellar object that got captured by Jupiter and forced into this kind of crazy orbit. I don't know why it keeps doing this. There's another comet that has actually moved into our solar system called Makold's Fujikawa Iwamoto, discovered by 2 Japanese astronomers and Donald Makols on November 7th, 2018. This one came through our solar system. It is leaving our solar system. So this is a hyperbolic orbit as well. There is a possibility, I haven't seen what the orbital eccentricity of it is, but there is a possibility that this was something that got yanked out of the Oort cloud in a weird way by Neptune and Jupiter and is just a little bit hyperbolic. So, but there's also a good chance that it's interstellar as well. And others are on the way. Oops, I don't know. I'm just hitting all kinds of things. Oh, I think maybe when these, I don't know. All right. There we go. So basically, this is again from the Galileo Project people at Harvard. Diptajyoti Mukherjee, Amar Siraj, Hytrak, and Abe Abilob at Harvard. They expect that the Vera Rubin Observatory, formerly known as the Large Synoptics Survey Telescope in South America, should be able to detect 1 to 2 50-meter sized interstellar objects per over its lifetime. So it's possible that we will find more captured objects in our solar system and actually be able to visit them. And they also estimated, this is another study from the same team. This is their primary research focus, but it does make me wonder how many surveys in different areas they're releasing. But they estimate that about 7 interstellar objects pass through the interstellar solar system every year. I don't know if this battery is dying or what, but so what's next? What can we do to get more information other than using the Vera Rubin Observatory? Well, there are some plans to get ready for the next time we get a visitor like Oumuamua or Borisov. The Comet Interceptor mission was selected by the European Space Agency in June 2019 as a fast class mission to intercept. So basically it's going to be 3 spacecraft that they're just going to park out at Lagrange points in the Earth's, orbital neighborhood and just hover in those places until we detect something. And then all of them will set off for the thing that we detect when they're given the signal to. So to increase the chances we can catch up with it and also to get views of it from different angles. So the idea is if they can get close enough, they can 3D model the object. And another project, and this one feels like this was announced 2 weeks after the discovery of Oumuamua, is the idea is to have a solar sail craft, and over time it would accelerate fast enough to catch up with some of these objects. They're still working on this. I think they've given up on the idea of actually catching Oumuamua and Borisov but they'd like to be ready to catch up with the next one. And finally, the Interstellar probe. This is a little different. This is not intended to catch up with the interstellar object that is entering our solar system, but instead, this is the goal of this is to actually get to Alpha Centauri and try to send back data for as long as it can. And so this, the goal would be to reach 1,000 astronomical units and then continue on. So
funded project.
This one, I think this got introductory funding. This was from Johns Hopkins. So I think it got funded enough to pursue it. I think they're trying to pitch it as a NASA exploration mission. So I don't think it's gotten NASA funding to actually build it, but they're continuing the studies of it. And so the idea is to get to 1,000 astronomical units within 15 years, which would be 3 times faster than the Voyagers.
So how long does it take to get to wherever it's going?
It wouldn't get to Alpha Centauri. It would still not get to Alpha Centauri before 10,000 years.
Oh, okay. Gotcha.
But it would at least get. And the idea, so the problem with the Voyagers is they got out into the interstellar medium, but they're not designed to collect any information about it, and their power supplies were pretty much run out by the time they got out there. So they're just sending back very basic telemetry data, but not a whole lot of information. So the idea of this is that it could actually sample, it could actually conduct some kind of research out there. I hope they have a really good battery.
Yeah, really.
So, yes, Dale.
You know, I mean, the radioisotope source that's normally used is plutonium. Oh, I forget which isotope, but those things run down in 80 years or something like that. There are other isotopes that are longer lived, but they don't get as hot, so you don't get as much energy.
Yeah.
You know what they're planning by using?
No, this was still, it was pre-design phase. It was sort of pitching the feasibility of it. So Dale just said the typical nuclear energy source you would use, plutonium-235, would have a usable life of about 80 years, maybe, depending on the size of it. And so whether that would be long enough or whether they needed to find a different source. And so that's as far as the story goes for right now, but it may go further in the future. So that's all the slides I have. Let me get back to the Zoom here. Oh boy. Do I have to stop screen sharing? Maybe I can stop screen sharing. All right, are there any questions on the oh boy, are there any questions on the Zoom? Yes, Laura.
Kuiper belt sort of disk heating as the Kuiper belt is big sphere.
So the Kuiper belt is the same stuff that formed in the inner solar system. It's just it was the disk of the sun formation. The Oort cloud formed in a different process than the disk of the solar system did. So the Oort cloud kind of formed sort of on the edges of the main, star forming region. Yeah, it's I mean, I don't fully understand, I don't really understand. Yes, Dan.
I mean, so they can hear it.
Sure.
The question Laura is asking is, why is it a Kuiper belt and an Oort cloud? Why isn't it an Oort belt? It's also an asteroid belt. So the idea is you had this almost formless cloud of gas and dust that the solar system formed from. And there was all kind of twirling motions in it and stuff. And the gas and dust particles kept colliding with each other until the dominant swirl came to dominate and it formed a rotating disk. That's why everything in the solar system rotates the same way in a belt. You know, the planets are roughly coplanar in their orbits, so is the Kuiper belt. So then why not the Oort cloud? Because way out there on the edges of this cloud of dust and gas, the collisions were so seldom that they're inclined enough to find a dominant direction of rotation. This material was too dilute way out there. So it formed all these frozen, icy things that we call comets, but they didn't adopt the same swirl pattern that the stuff closer in did.
I have a comment. So the clouds, because there's not enough gravitational attractions to just make it move any closer.
It's basically, there's, you know, the gravitational force of the sun is strong enough to capture it, to keep it from leaving, and to carry it forward as the sun moves through space, but not enough to pull it in either. Yes.
No, let this, new gentleman go. Repeat now, is the Centauri system has something like an Oort cloud?
That's a really good question. I would think that it would. So Troy asked, does the Alpha Centauri system have something like an Oort cloud? I don't know for sure, but I would think that it would have something like it. Yeah. Yep. Yeah, for sure. Yes, Dale. And so Troy said, would they be would the different Oort clouds be interacting with each other?
I mean, basically you have these huge clouds of dust and gas all over the place. And so similar dynamics, we assume, happen every time a star forms out of one of those clouds of dust and gas. So eventually you get this disk of rotating stuff, but outside of that disk, you have stuff that didn't interact with each other strong enough to form that same swirling motion. So based on the current thinking, there should be an Oort cloud kind of thing out there far enough out from each star. If you ask where's the boundary of those Oort clouds, it's about halfway in between each pair of stars, if the stars have similar masses, similar gravity. So our Oort cloud gets out just so far, and at some point it's the Oort cloud of another star. And roughly in between those stars, who knows what's happening, you know?
So basically it just makes up our interstellar gas of our galaxy between the stars.
Something like that, yeah.
Well, and then there is interstellar, there's galactic medium, there's gas that isn't attached to a star. You know, there's nebulas just floating through the galaxy as well. But these Oort clouds are specifically sort of attached to the gravitational, influence of one particular large body or another. But they're also really diffuse. Like, you think of an Oort cloud having billions of objects, but the surface area of that sphere is so large, so inconceivably large, that those objects are still not really within sight distance of each other. Like, if you think of the Millennium Falcon flying through the asteroid field or something, like, in reality, they would be like, hey, look way out there, there's one asteroid. So yeah, it's not nearly as exciting in real life as in the movies. Yes.
Well, I'll just get up here and ask you questions. So, I kind of picture all this search for all these objects, kind of like the best. I'm sorry. I apologize for that. I picture all this kind of like looking for the best fishing hole.
Yep.
Instead of like St. Clair up in the sky. So all these folks that are finding these things, there's some little kept secret or some special knowledge that I don't understand that they're using?
No, I think, there are more sky surveys going on now than ever in the history of humanity. And the technology is improving. The detection strategies are improving, and the degree to which we can react is improving. So we have, Hubble is still in operation. We have the James Webb coming online, and so we can get early. James Webb is going to be doing some sort of minor planet research in addition to all of its cosmology research. So there's just a lot. There's a lot of stuff available.
So they all kind of work in concert where they all say, well, I'm gonna look here, you look there, so we all won't be going over the same.
And then when somebody finds something, everybody looks at the same thing. Yes, sir.
I have a question. We're trying to get so far out, right? This falls in that category where I'm not sure it's all fully thought out yet. We're trying to get so far out there, but we can't achieve a speed where it's gonna occur anytime soon. Well, I know these other ones, it might be 300,000 years, but can we hitch a ride on any of these interstellar objects? Maybe the technology's not here yet, but hitch a ride with this thing that's going at ridiculous speed.
I think that would be the dream. Like that would be definitely, if you could intercept. The problem is you'd have to intercept it and then have some way of attaching to it that wouldn't just rip out of your spacecraft or whatever. But but if you could make it work, that would be an amazing way to get a boost. Like literally can. Yeah, but the thing is, like the shock, the jerk force when when you make contact with it is going to be incredible. And also, how are you gonna impact it enough to actually, have it?
Engineers in the future.
Yeah, no, it's a great idea. Like that would be like the ultimate dream. That would be a fast ticket out to another star comparatively. But even so, like Comet Mach-Holt, that's still going to be 20,000 years before it exits the solar system. So
I guess that's a reflection of where does our fuel come from? Well, we could hook onto something that's already got the fuel.
Yep, for sure.
There.
Janice.
Change the subject back to science fiction.
All right. I don't see Gary Ross, so I think it's okay.
Well, I started reading the book. Imagine that, I read a book. Anyway. Where am I? I read lots of books. Science fiction is my favorite genre. And up popped on my Kindle this thing, Intrepid, the dawn of the interstellar age. I mean, it is thrilling. It is, I'm only a third of the way through it, but it's like, I can't wait to just go to the next thing, but I always fall asleep when I'm reading. The title is Intrepid, Dawn of the Interstellar Age. And don't ask me who the author is because I never remember names. So it's good. Kindle is like $4.99 or something. No.
All right. I don't know if anyone's looking at YouTube, but were there any questions on YouTube, or are we ready to wrap it up?
I think we can wrap it up.
All right. Well, I will hand it back to Dale to finish it off.
Well, that was fun. Thank you again, Jonathan. Our next star party and open house at Stargate Observatory will be Saturday, January 27th. That's the fourth Saturday of the month, which is when we do that. Our next indoor meeting will be at Cranbrook on Monday, February the 5th. And our next meeting will be tonight. For those who are interested in going to the National Coney Island on Groesbeck, just south of 12 Mile Road. I understand from Jonathan that he and Diane are going to be there. I'm planning to go there. If you'd like to join us, you're welcome.
Just go here on the right.
Yeah, it's real close to
Just
here.
head east on 12 Mile and then make a right on Grossman.
Yeah.
Or just go into the parking lot.
Right. Yeah, it's almost right at the intersection of Grossbeck
Oh,
and
yeah, I
12
know
Mile.
that side of the town. I'm just it's easy to find.
Okay, this was fun. Have a good night, everyone.
Good night.
One characterization of dark energy, dark matter. Going